Thank you very much. Yes, examples, derivatives, functions involving e, all about the special exponential function with base e. So let's dive right into the playlist. E to the power of x, I'll do it like this. Here is always f of x, and here the derivative e to the power of x. Again, for those who want to go deeper, what's special about this? Why is the derivative of e to the power of x exactly e to the power of x again? I can only keep recommending it. It's really fascinating to understand that you have a power here, base raised to exponent, and e stands for Euler's number. Where does it come from? Why is it like that? The rest should actually be pretty straightforward. If you have multiplied a number, then a constant factor, it remains 2 times e to the x. If it said 10 times e to the x, it would be 10 times e to the x in the derivative. If something is now stuck onto e to the x, as some people say, like plus 10x squared, for example, then please look, you have the part here with the special base. A to the x, its derivative is e to the x, and here are the basics that you already know. For polynomial functions, namely 10x squared differentiated would be plus 20 times x. You just need to watch out for that. Then comes the important step for understanding what happens if we have e to the, and now in the exponent, for example, x squared, then you have a composition. Here too, I can only recommend taking another look at the composition of functions and not just memorizing it. Yes, basically that's again e to the x squared, so the part with e stays the same, but I also multiply by something. You could also ask the question now about 2x, that's the derivative of the exponent, which would be the derivative of the inner function here, namely x squared. Now you can combine again. You have again a number times the exponential term, in this case e to the x squared. The constant factor 10 remains. E to the power of x squared also stays, but it's still multiplied by the derivative of the exponent. That would be 10 times 2, which is 20, so 20x times e to the power of x squared, and now again here as well. I always say, once you've recognized the structure, the danger is gone. 10e to the power of x squared, now pay attention. For example, if I now do minus 20x, that would be the part that's been derived, as we've just clarified. It would be 20xe to the power of x squared, and now there's still minus 20. And what would minus 20 derived be? It's not a constant factor, but rather it's plus. So the minus drops out. What if it said minus 20x? Minus 20x derived would be minus 20. And now, attention, maybe the next crucial step, what if it said 10x times e to the power of x, for example? Now you have the multiplication of something with x, the argument, and again with the argument x, and now you would need the product rule, so u times v plus u times v. U part, v part, you can of course also mark them with colors to make it even clearer. You derived, and now you're mentally in this part. Differentiate, it's 10 times the v part stays the same, plus the u part stays the same times. V is e to the power of x. And here, it's often made a bit nicer, written in such a way that you factor out the e term. And then you would have written here now, if I now... That would be e to the power of x, open parenthesis 10, 10 plus 10x. So that was already a lot to take in. I also hope you understood it. You can find many more examples in the playlist, and if you can recognize these steps, you should get through it easily.